Well, today we're going to pull back the curtain and demystify the whole research process. How we go from a simple gut feeling to cold, hard data. So let me just start by asking you this. How do you know the things you know? Really think about it. Is it something you've just always heard? A hunch you have? Or is it something you could actually prove to someone else? Asking that one simple question is the first step toward understanding what makes real research so powerful. You see, most of the time, our brains are kind of running on autopilot. We have these default ways of knowing that are fast and easy, and look, they get us through the day. But they've also got some pretty serious bugs in their software. Let's break a few of them down. First up, we've got tradition. This is the stuff we believe just because. Well, it's always been that way. A perfect example, the idea that we only use 10% of our brains. Now, we know from brain scans this is totally false. We use pretty much all of it. But that idea has been passed down for so long it just feels true. That's the power and the real danger of tradition. Then there's intuition. Ah, yes, that gut feeling, that hunch, the I just know it feeling. But here's the thing, our intuition can be wildly wrong. For instance, tons of research on eyewitnesses shows that how confident someone is in their memory has basically zero connection to how accurate it is. A gut feeling feels powerful, but it's just not evidence. And of course, we have authority. We believe something because someone in charge said it. The trap here is when we confuse someone in an authoritative position with an actual authority on the subject. Think about the old Thanksgiving myth. Turkey makes you sleepy because of tryptophan. Sure, turkey has tryptophan, but not nearly enough to knock you out. The real culprit? It's the mountain of carbs and just eating a huge meal. So, here's the bottom line. Tradition, intuition, authority, these things help us make quick decisions in life. But they're all subjective. My gut feeling can't be tested by you, and your experience might be totally different from mine. There's no way to reproduce the results, and that is exactly why we needed an upgrade. So let's talk about that upgrade, the scientific method. And listen, this isn't some dusty thing just for people in lab coats. It's a really powerful, systematic toolkit that anyone can use to cut through our natural biases and get to answers that are actually reliable. At its heart, this is what we're talking about. It's a logical, step-by-step process. But the two magic words on this slide are reproduced and consistent. This means if I do an experiment and tell you exactly how I did it, you should be able to do it too and get the same results. That's what separates science from just having an opinion. And this is the roadmap for how it's done. It's not a straight line, it's a loop. You start with a question, you make a plan, you do the thing, you crunch the numbers, and then, and this is so important, you share what you found. Because sharing those results almost always sparks new questions, and bam, the whole cycle of discovery starts all over again. So what is all this research trying to do? Well, it usually boils down to one of four goals. First, you just want to describe what's going on. Then you try to explain why it's happening. Once you can do that, you can start to predict what will happen next. And in some cases, the ultimate goal is to actually control or influence the outcome. Okay, so we've got the method. But how do scientists actually look at a problem? Well, you can think of it like they have two main lenses they can use to view the world. One lens focuses on numbers, and the other focuses on stories and narratives. And those two lenses are called quantitative and qualitative research. Here's a simple way to think about it. Quantitative research is about objective numbers. It answers questions like what or how many. Qualitative research is about subjective experiences. It answers the question why. One gives you the statistics, the other gives you the story behind the stats. Let's start with quantitative. This is the world of hard numbers, graphs, and statistical analysis. We're talking about big surveys, controlled experiments, anything that gives you objective data you can literally count and measure. So what's the power of just one number? Well, take this one, 65%. In Stanley Milgram's infamous obedience experiment, that is the percentage of regular, everyday people who are willing to deliver what they thought was a fatal electric shock to another person, simply because a guy in a lab coat told them to. That one single number revealed a deeply uncomfortable truth about human nature that no gut feeling ever could have. Now let's switch to the other lens, qualitative research. This is where we dive into the why behind those numbers. It's not about counting things. It's about understanding people's experiences, their motivations, their feelings. You do this through things like in-depth interviews, focus groups, or just observing people in their natural environment.
For example, imagine a drug trial. The quantitative data, the numbers, might show that the drug reduced symptoms. Great, success. But what if qualitative interviews with the patients reveal that the side effects were miserable or that the drug gave them an unexpected boost in their quality of life? That's the rich human context that numbers alone can completely miss.
So we have different methods and different lenses. But what's the end game? What's the whole point? Well, research usually has one of two major purposes. Are we just trying to learn something new, or are we trying to solve a specific problem? This brings us to the difference between basic and applied research. Basic research is all about curiosity. It's about expanding the boundaries of what we know, just for the sake of knowing it. Applied research, on the other hand, is totally solution-driven. It takes the knowledge we already have and uses it to fix a specific, real-world problem. So, a basic research question might be something like, what does anxiety in teenagers actually look like? The goal here isn't to fix anxiety, but just to deeply understand and describe the phenomenon. It's about building that foundational knowledge. And that foundation then fuels applied research. The question becomes, okay, now that we know what it looks like, what causes it, and what kind of program can we build to actually help? You see how one feeds directly into the other? Basic research builds the library of knowledge, and applied research checks out the books to go build something useful. Okay, so after going through all of that, methods, lenses, goals, you might be wondering, why does any of this matter to me? Well, because in today's world, being able to think like a researcher is basically a superpower. And maybe the biggest takeaway of all is that these methods aren't enemies. They're on the same team. The absolute best, most complete understanding comes when you combine them. The numbers can tell you that there's a problem, but it's often the stories and experiences that tell you why there's a problem. You need both to see the whole picture. So think of this as your new mental toolkit. The next time you see a headline about a news study, you can now ask better questions. Was it quantitative or qualitative? Was it basic or applied research? Who did they talk to? This is how you start to evaluate the strength of a claim for yourself and how you separate real evidence-based science from pseudoscience and noise. So I'll just leave you with this final thought. Now that you have this toolkit, the next time you come across a new study or a big claim, what's going to be the first question you ask yourself?